Alright, we're going to talk about three-dimensional objects. You see a bunch of them right here. You're actually looking at all these objects, though, ironically enough, in two dimensions because you're looking at it from a flat screen. We're going to talk about each one of these things in a little bit more detail. Before we talk about the names of these objects, though, there's some vocabulary we have to understand. A polyhedron, we're going to see that in just a second. Then there's the parts of the 3D objects, the face, the edge, the vertex, and kind of the names for them too. We have different names, pyramids and cylinders and cones and prisms. So we're going to go over all that in this video. The first term you just saw right there is a polyhedron. And it's a three-dimensional object or solid figure with flat surfaces called faces that are polygons. And a polygon, in case you didn't know what that is a closed figure that is made of line segments. So for instance, a circle is not a polygon because it's not made of line segments. It's all rounded. So you can see this picture here, this triangle-ish object. It is a polyhedron. Why? Because it has flat surfaces, as you can see. These are all flat, and they're also polygons. There's a triangle right here. A triangle is a closed figure made of line segments. And then there's also these rectangles right here on the edges. How many faces does this object have? Well, we're going to look at the word faces right now. So this right here, this triangle part is one face. You can see the rectangle here is two faces. And there's the rectangle over here, that's the third face. The other faces you actually can't see, but on the other side of this triangle, there's another triangle. So that would mean that there are four faces, and then over here is another rectangular face, and it is the fifth face. So this would actually have five faces. When two faces of a three-dimensional figure share a side, they form an edge. So you can see these three arrows here are pointing to the edges of this shape. So there's an edge right here. There's an edge right here. And then there's an edge right here. So there's a bunch of edges. How many edges does this object have? Well, this would be one right here. This would be 2, 3, 4, and then there would be 5, and then there's a 6 right below this one, and then there would be a 7th and an 8th one right below there. And then also there's a term called vertex, where if 3 or more edges meet, that's where the vertex is. So you can see this arrow right here is pointing to the vertex. That's where this is meeting, this edge right here. Then there's this edge right here, and this edge right here. So there's 3 edges meeting right where the vertex is. How many vertex does this, or I shouldn't say vertexes, the plural is, as it says right here, vertices. There are 6 vertices in this three-dimensional object. And we're going to go over this object's name in just a second. So you can see the different vocabulary terms we have with this polyhedron. There's the vertex, the edges, and the faces. And you can see that there are, in this shape right here, 5 faces, right? 1, 2, and then through there, that's 3, and through here is 4. And then a 5th face on the bottom. There's 8 edges, and then there are 5 vertices. You're going to notice something with these numbers, hopefully, in just a second. This shape right here, we're going to have a name for it, like I said, in a second. I'll give you a hint, though. The name, you can see there are 5 sides right here on this figure, and then there's, looks like these are rectangles or parallelograms right here. So that's kind of going to give us a hint as to what his name is. But anyway, there are 7 faces here, and there are 15 edges. You'd have to really stop and think and count them, but 1, 2, 3, 4 right there, and then 5, and then 6, 7, 8, 9, 10, and then 5 more on the other side with the pentagon, 11, 12, 13, 14, and 15. So the 2 pentagons on the end make up 10 of those edges, and then there are 5 in the middle here. And then finally 10 vertices. There are 10 vertices, or 10 places where 3 edges meet. One of them is right here. If you can't tell, there's a way to check the amount of edges and faces and vertices to make sure everything you did correctly. And the formula we have is to add the number of faces. There are 5 here, with the number of vertices, and there are 5 here. and that equals 10, and then subtract the edges, which is 8, so 10 minus 8 is 2, and you should always get 2 when you do that. So if you add, again, faces, 7, plus vertices, 10, that's 17, minus 15 edges, it equals 2 again. It's a pretty little cool formula just to check your work, because I know looking at this shape right here, especially when it's in 2D, it's tough to tell how many edges it has, for instance. So this shape right here, it has 6 faces. Can you guess how many edges it would have? I'm going to let you pause the video and see how many edges it has. See how many vertices it has. Pause the video, see if you can figure it out. 12 edges, and then vertices. How many vertices would it have? That would be 8. There would be 8 vertices there. So you could probably have been able to tell just based on the fact that there are 6 faces. 6 plus something minus 12 equals 2. So that's another way of thinking about it. This one right here, how many faces, how many edges, how many vertices does it have? Now based on this, we could say 5 plus something minus 9 equals 2. Well, that something I think would have to be 6. So there would be 6 vertices here. Finally, we get into the names of these shapes. A pyramid it has one base, and the other faces are triangles that come to a point. So anytime you see a lot of triangles in a polygon, chances are that's a pyramid. A pyramid is named for the shape of its base, so the bottom of the object. So if we look at this one right here, you can see that there would be a square. It's tough to tell that it's a square maybe from that angle, but you could certainly call it a rectangular pyramid. And then we have a triangular pyramid with a triangle at the bottom. A cone has a circular base. You're all familiar with ice cream cones, I hope. So we kind of know what this shape is all about. But you can see that it's not a polyhedron because not every surface is a polygon. You can see really none of the surfaces is a polygon because this isn't triangular right here. A prism is a polyhedron with 2 congruent parallel bases and other faces that are parallelograms. So a prism is named for the shape of its base, same thing as a pyramid, right? So that's a rectangular prism. You can see that's a hexagonal prism. We saw one earlier that was a pentagonal prism. And then there's a cylinder. It has 2 congruent parallel bases, but of course these are circular. So again, this wouldn't be a polyhedron because not every surface is a polygon.